Hello everyone, welcome to the second part of my Geometries Node landscape tutorial. I apologize for some sneezing or coughing. I'm actually running through a COVID infection, but good luck for me. I have nearly no symptoms, so everything's fine. So we are now in part 2 of the tutorial, and in the last tutorial we already created the ground and the water, and now in the second part we will do the rest. You should all see now something similar to that. Our water and our ground. We put it in some frames to get things organized, and what I have already done is to add my assets. That's not part of the tutorial how to create these assets. Maybe I can do that later. And I also added some materials, and to do that we go into the material node and just add some water material, tutorial water and tutorial ground, and there we have it. Maybe we take a short look into the material. The water material is nothing fancy, just a noise texture. Let's jump into the right material, tutorial water. There we have it, just a noise texture and a bump. No further things are added. And the ground material, no, that's the wrong one. Tutorial ground, there we have it. Is also just a simple material with base color, roughness, bump and normal map. The important thing is that you set your texture coordinate to generated, otherwise it will look weird. And that's all. Back to geometry nodes, and now we can start with adding our first asset, and I think we will start with our grass. So let's add some new node. We will need a distribute points on faces node. We will need an instance on points node. Scale instance node. And to get some random values, we will add a random value for the scale, and we will add some random value for the rotation. Let's set that to a vector. And of course we need our collection, therefore we just drag and drop the green grass collection to our node editor, and there we have it. Important, you activate separate children, reset children, and in instance on points you activate pick instances. So first of all we will connect the Z position node from the ground with the distribute on points node. After that we connect points to points, instance with instance. We can also add a switch node. Maybe you want to turn the grass completely off, and the switch node will go into, where do we have it? Hello, in our join geometry node. And of course we have to add our instance itself. And there we have it, our grass. Actually, it's a little bit too big. It has no real-world measurements, but we will fix that later. Now we can add the random values. The best value to scale, I figured out, is 0.3. That is the minimum size of the grass to get some variation in it, and the maximum size is 1. Let me check what size do we have for our grid. Oh, that's really small. Let's set it to 10 and 10. Now the grass looks more natural in its size. Let me add some RGB curves so it looks a little bit more natural, something we can work with. Maybe something like that. That will do. Okay. Now let's set some random values for the rotation. So we put the random value into the rotation. I leave the scale node input from that because later we will connect the scale input with the nodes from the water, that the water will automatically adapt the vegetation, and but this will come later. Now the best values for the rotation are 1.0, 0.3 and 15. That rotates the grass only slightly in the X and Y axis, but in the Z axis it will a complete random value. Let me increase the density a little bit so that we can see something. As you can see, it looks pretty natural. There are no tiles in it, no repetition, so that looks good. And now we can add the nodes for the adaptive water level. First we set a new frame around our grass. We name it green grass. Green grass. And now we add a position node. The position node will give us the position of each grass instance, and the nodes will look to each grass instance whether it is above or below the water level, and if it is below the water level, the instance will be deleted. We will need a separate XYZ node. Math node. The math node we set to less than. Then we can copy that and set that to subtract with clamp. And the most important thing, we need a map range node. The map range is the most important node. It will clip the grass, clamp the grass, delete the grass above the water level. It compares, it's a compare node. So first of all, we connect the position node to the vector. And now important, the Z value, because we only need the Z position of the grass, we put into threshold. Then the value we connect to the upper value and the lower to 0. And that one we give to value, deactivate clamp. And it took me some time to figure out the right values. So that what works here is 2 and 1. You can play with the values and see what happens. And now we put the map range into the scale. So what it does actually is it does not delete the instance, but it scales it to 0. That what is actually the same effect. So the only thing what is left to do is that we get our level of the water, and therefore we connect the value from the less than node with our already created water level, and the water level was, I think it was that one. So let's have a short control. I think it worked. I can see no grass below the water and grass above the water. And if I change the value, the water sinks and the grass grows. And maybe if and it seems to work. No grass above the waterline. Now the only thing that is now left to do is copy that part of the sorry, is that part of the node connect, we'll try to disconnect that and connect the mesh with the Z position node, and after that the switch with the geometry, joint geometry node, and we can add another collection. Maybe we can add the dandelions. Just drag and drop, connect it, activate separate children and reset children. Maybe I set the density a little bit too low, too high, so maybe it works now. Okay, that looks good. And as we can see here, there are dandelions and grass. Looks good to me. And you can go on with the rocks, the flowers too. The only thing that changes a little bit is when you want to set the underwater rocks. Therefore we copy that whole thing, disconnect the instance node, connect the mesh with the set position node, and the switch with our joint geometry node. Now, if I want to have the rocks below the water, I take my rocks. I will just switch that off, connect it with the instance, activate separate and reset, and as you can see now, the that would be the node for the rocks above the water. We forgot to connect that with the water level. So that and the dandelions too. Where will we have it? Right here, the dandelions. So, and if you want to create the rocks underwater, you just change less than into greater than. And there we have it. We have the rocks underneath the water. And let's have a quick control. It works. Grass and flowers above and rocks below. Now let's change it to 0.5 and looks good to me. Some of the stones are too close to the water ground. That's why you can see them, but technically they are under the water level. Now what you can add now for the rocks is the set control. Therefore you can create another value, input value, and plug that into, no, that's our grass. No, we forgot to rename it. Dandelions, and that was our rocks. Now to control the set level, we add another value, put it in here, and connect the value with our, no, we need a combine X, Y, Z. We have to be careful that we do not disconnect other strings. So connect the value into the set and the combine X, Y, Z vector output into the, where do we have it? We need a transform value. I forgot that. Transform value. We put the transform value between scale instances and switch, because it's important that we move the stones after the instances has been positioned and scaled. Now we can connect the combine XYZ output to the, where do you have it, translation, and now we should have control about the set position of our stones. There we have it. Okay, I think that's all. We are done with our cool modular nature asset. The important thing that I realized, some graphics card, especially some graphics card with low memory, for example 4 GB or maybe 8 GB, that's not low, they have problems with the vertices, especially from the ground. When I rise up the vertices above 1800, some graphics card have a problem, but around 500 and maybe 800, even graphics card with less VRAM should handle the scene. That's something important, because I realized that. But that should be all. Something important again, you should turn the texture off from each asset. You can find you have to click one asset and then click on the object properties and change the display from texture to bounce. That will increase the speed when you are not in rendered mode significantly and gives us a much better workaround. Okay, thank you. That's all. See you.